Yes. Now today we'll continue with the economic analysis. Yesterday we discussed about some definitions. Today we'll see some more definitions on economic analysis of solar energy or else renewable energy sources. We'll try to take some simple numbers. Okay. It's coming to the next part, that is present worth or discount rate or the net present value or the net present worth. And also we need to discuss about the important factors, that is return on investment and payback period. These are the important or very important factors which one need to consider for any plan to be set up by considering some payback period or the return on investment. So today we'll discuss what is the importance of these terms. So first I will consider the present worth of the plant or the money if I consider. So anytime if you talk about any purchasing or the installment of the new plant, so every time we need to consider at present what is the cost or what is the worth of that investment. So in that term, we are going to consider this present worth of money or the present worth factor. So this is required sometimes in the future, so that is obtained by calculating how much would have to be invested at a rate called the discount rate. Once you start investing, okay, at present if you invest, so what may be the future amount to be paid or by the client, or else one can consider. So by the down payment, if you consider how many total installments we need to pay. So at present, what is the cost involved in it? Okay, like that we can consider. So in that, we are going to consider the rate called as discount rate. At what rate it is going to be discounted at present. Maybe in future it may be very less price or it may be very high price at present. So that we need to consider in this point. So these are all things you can consider or you can understand more detail in the problem also. Okay, discount rate. So in today, in order that required money would be available when needed in the future. So if I read the complete paragraph like the present worth of the money required sometime in the future is obtained by calculating how much would have to be invested. Means the overall present worth or the discount rate, all things you just observe the future for future, how much is the requirement is there or how much money I should pay or how much I should earn. So that all depends on the discount rate, what is provided at this time. Or after paying some interest rate to the company, so company will be earning some value. So these rates we are going to find out in this present worth factor. The next term is the net present value. So this is also used very often, like same thing, present net present worth or net present value, both are same. So this is often used in place of cumulative savings. As I said, you for a given number of years, we want to find out for a lifetime or for a given n number of years. So net present value we need to consider so that whether it is worth to purchase or worth to go for the alternate plans, so that later we are going to get some money from that or later we are going to be profited such that whatever the investments are going on now with the other plans, that can be overcome by this solar system or the renewable energy sources. So that factors are called as present worth factor or the net present value. So it's obvious that if a solar system is to be economically beneficial or viable, the value of cumulative savings over a reasonable period of time or the life cycle savings must be positive. So whenever if this at least if the payback period is zero or the net amount what is invested at present and after 10 or 5 years, say for example, if the investment and the advantage or the profit gained by that system, if at least it crosses zero or whether it is going negative to positive side, that itself indicates that system is a economically viable system. So this we need to consider by using these cumulative savings of the life cycle savings, if the amount is positive or not. Okay, it is obvious that it, in a given situation, these values will decrease as the market discount rate increases. So the discount rate for which the value of cumulative savings or the life cycle savings is zero is called the rate of return. Means once we reach this 0 point, okay, say for example today I will invest in one plan, say for example 10,000, and after 5 years I'm going to uh, receive all the benefits whatever I have invested today. After 5 years, my rate of rate of return is exactly zero, or the savings will be zero. Okay, returns will be zero. From that point, whatever you earn, okay, after the zero position, okay, so that point I'm going to get it as the profit. So this point we are going to call it as rate of return. The discount rate for which the value of here, this point is very important. Cumulative savings and the life cycle savings, whatever you are trying to do, if it crosses the 0 point, then that point we are going to call it as rate of return on investment. I'll consider one example here to understand what is the importance of this rate of return. You can see this graph here. Yesterday also I have taken this graph once again in just observe. Yesterday. Yes. Yes, here you can see investments I have done say for example 4,000. After 5 years I'm getting all the benefit. So whatever I have invested 4,000 rupees, so that 4,000 rupees in the form of earnings or the returns I'm going to get at this point, okay, after 5 years. So once this point is achieved, then I can say some rate of return is possible now, or the rate of return point is reached. After this, you can see whatever the investment is done for 4,000 rupees. Later, after 5 years, from day one to the 5 years, what I'm getting everything is in positive or everything is in profit manner. So from this point, we are going to define the rate of return is going to be there in this plan. So to showcase that point, I have taken this. Is that clear? So next, what is the point we need to discuss? That is payback period. So another term which is used here to test the economical viability is the payback period. And many times it is also said that in many books or many references, whatever you find out like savings, profit, the discount rate or the inflation of the price, or net present value of the return of return, rate of return. Finally, one should find out the payback period. What is the payback period for a given plan or a subsystem? Until and unless if you find out the payback period positive or anything is payback possible from the given plan, then it is nothing to do with the economical viability. So once this payback period is possible, then anyone just by closing his eyes he can go for the plan and he can achieve the economical benefits. So now we'll see what is this payback period, what is this importance in the economical considerations. Okay, so it is defined in many terms. So here I have taken some two definitions. Very simple to understand. I'll read the just points here. So this is the time needed for cumulative savings on fuel or electricity. So whenever I talk fuel or electricity, it is from the outside, not from the on-site. Means it is not from the solar, it is from the grid or outside connections. So that saving we are doing by connecting a on-site solar system. So that cumulative savings for a given number of years, whatever you are doing, and time taken for that savings. So time needed for cumulative savings on the external fuel or electricity supply or income, okay, or income from the power fed to the grid. So whatever you have generated on site, you may get some income also or some profit when you are supplying to the grid without any taxes to the government. So that income or the profit to become equal to the total initial investment means once you reach this point, whatever I shown the graph, once you reach this 0 point where income is equal to the sum of cumulative savings or the cumulative income is equal to the investment on the entire plan. If once it becomes zero, then I can talk about the payback period. So the payback period for for the given system. Here I have what I have considered was 5 years. Even the rate of return starts from 5 years. Okay, so payback also starts from 5 years. So this point is very important. If this point is very less, so for example, less than 5 years only, if you start with the payback, that is well and good. Economically, you will be very good. And if the life is very high and the payback period is very less, in such case also we need to consider which plant is suitable for the given application. Okay, or else here also you can see how we are going to considering the initial cost, payback time, return on investment, as well as the savings. So in this graph, you can see whatever the installment you have done, or the initial payment you have done. So until some period, you cannot get any profit. So whatever the profit you are getting, that all things will be uh, used just for paying the installments to the companies or the banks. So one point you reach after some years, such that the investment whatever you have done and the profit what you have earned, both will be balanced. So from that, I'll get some payback or I'll get some returns. So return on investment, now you can see the green color sign. After some point, I will be getting the return on investment, which will be gradually increasing in a positive manner, which is shown in the green color. And until its life cycle savings, you see, until the life cycle after 25 years, the return on investment you can just check here. What is the investment? $8,000 or 8,000 rupees. But what is the return? It is in 65,000. So like this, one can analyze the economic viability of these systems. And one can also check by going by which plan I can save more and I can how much I can get on return on investment or what is the payback period. So payback period means the timeline taken to make the investment and the returns zero. The net sum of these 2 points will be zero. Okay, or else I can define in other way also. What is the other point? The time needed for cumulative savings to become zero. Same thing. And the time needed for the annual savings to become positive. Means the profit should increase. Okay, the savings of the investment should become less. At that point also I can tell it as the payback period. The time taken to reach that 0 point is the payback period. After that you have return on investment. So that value has been determined by using actual savings from year to year or for a given number of years or by using the discounted value of money. It also depends on the value of money or the value of the plant. Okay, so these are the different economics. Some graphs are shown here. You have to understand a little bit more and to get the equations to find out the present work factor or the discount rates or the rate of interest, okay, or the payback period. We have some analysis here. So first thing is the life cycle costing. That is again life cycle savings. Okay. The commonly used method in engineering economics studies is evaluating. So I think already you have completed engineering economics subject. At this moment, I'm not focusing more on those equations or how to find out the factors. We'll just focus here how we are taking the data from the given plans and how we are going to find out whether it is worth or not with discounting or without discounting, how it is working in the economical factors. But not going deep with economics as what we have discussed earlier or we have studied earlier. I'm focusing only on the plant basis. Okay. So that economic studies is evaluating the potential investment in life cycle. The method involves three essential components. One is the capital cost, is the investment, equipment maintenance cost for a given life, and the saving in future fuel points. So these things we need to consider for life cycle costing. So in life cycle costing, the sum of the capital and maintenance cost is compared to the present work saving estimated to occur from investment over the life. Means what is the capital and the maintenance cost is required to be invested for a given life of a plant. Okay, that amount of the cost that is compared to the present work saving estimated to occur from investment over the life of the equipment. The total life of the equipment, how much saving is possible as per the present value of money. If that is positive, then I can say the plant is viable. So this difference, what we are getting, is called as life cycle earning or loss, or also it is called as life cycle savings, or also it is called as life cycle cost. Okay. The next very important factor is the present worth value or net present value, or it's also called as present worth factor. To find this present worth, what is the present worth of this saving? So let us consider a series of escalating or increasing, okay, escalating in the sense increasing annual fuel payments. Assuming for simplicity, the payment at the end of the first year is say rupees 1. Only 1 rupees we have considered for it. 1 year. After 1 year, we need to pay 1 rupees for the fuel. Okay, for the given plant. It may be conventional plant. Then the payment at the end of the second year, okay, by increasing some uh, inflation factors, 1 plus I. So at the end of again third year, if you see, it can be taken as 1 plus I raised to 12. And like this, it will be increasing. So at the nth year, if you see, I may write in a similar fashion 1 plus I raised to n minus 1. So at the third year, it is 1 plus I raised to 2. In the nth year, it is 1 plus I raised to n minus 1. Okay. So these series of payments, what is required for a conventional plants, that payments, if you take all the sum of these points, then we can call it as the present worth factor. What is required for a life cycle of investments. So similarly here, the present worth factor again is explained in different ways. The money spent on fuel could have been invested to earn more income at compound interest. So many people will tell, apart from investing these in plants, better you can invest in some bonds or equities or in insurances so that earning will be more. So, so similarly, the best alternative investment also we need to compare. Is there any alternative to this plan, whether we can generate more profit or not? So that best alternative investment rate of return is called the discount rate. Okay. If it is good, then you can go for the other alternative, or else you can go for this same plan investments. Or also you can just compare with the conventional systems and you can just convince the government how much you are saving with the grid connection system or how betterment you are doing with the environment of the government so that you can claim some discount rate at the initial stage itself. Okay. So there this discount term will be playing the role. And also it allows us to assign a financial value to the passage of time. So there will be some value to this financial things. You may get also a good resale value also because of the renewable energy source. So considering these things with the different discount rates for the different years, they have written these equations. So assuming a period of 10 years for the fuel payments, so if you are going for the fuel payments, rupee one payment at first year. See, first year 1 rupee is taken, which discount rate if you consider 1 plus t rate to n minus 1. Okay. For second year, the 1 rupee is increased by 1 plus I with the fuel payments. So that I have taken 1 plus I. Discount rate will be increasing 1 plus d rate to n minus 2. So like this, all the discount rates are considered with the price of investment on the fuels and multiplied with that here. So the sum of above series can be written as. So what they have done, they have taken all the sum of these terms of the universe. So nth year sum will be 1 plus I raised to n minus 1 into discount rate. What will happen? It will come back to 1 because initially the discount will be high, but finally what you are doing, the discount rate will be overcoming by the fuel purchasing or some investment on the maintenance of the resale value. So all this discount will be becoming 1. So that is considered here. Initially the price value is 1. Finally discount rate is converted into 1. It is present worth factors. So with discounting if you want to find out. Without discounting if you want to find out, I can go by this value. Where in these equations we don't have any discounting factor. So the above value is the sum of present values in rupees is termed as the present worth factor. total benefit you got from the plant or total investment done for the plant, whatever the sum you take, that I can call it as for a given year as a present worth factor of the net present worth value. Okay, and this is obtained again by simplifying these equations. You can get it built up, and by this we are going to get some equations which are required for our numericals. Also, you can take one example here. At a discount rate of say for example 15%, sum of 100 rupees next year is worth of, how to find out the discounting, 100 divided by 1 plus p. If you take that 1 plus 15% is 0.15. If I take, it will be 1.15. So next year I will be discounted for 86.95, or you can say depreciation also. Or you can say that 86 rupees or 86.95 rupees if you invest today with the discounted value, then after 15% of growth it will be 100 rupees. So like that, you can take the discount now and later you can grow the money. Means it is for the banking sectors, how they can think of. Or else, whatever the investment you have done now, okay, later because of the benefits, every year if you get some discount or depreciation value, in such conditions it will be worth of this resale value. Like this, like this also can calculate. The next is finding the equation for the present worth. What they have done is again same equation they have taken. The value of the sum. Sum earlier they have taken 25.1 equation here. Yeah, the sum of these terms they have taken. So simplifying means they have divided some values and other things so that sum here, the sum what they have done by compound interest they have considered. So that compounding they have done with 1 plus d raised to n. So that 1 plus d raised to n is multiplied with the present worth factor and again divided by 1 plus d here. Dividing the equation to 25.2 by factor 1 plus I by 1 plus means the inflation rate as well as discounting rate will multiply and divide. So finally you can find out the simplified form of equation of the present worth factor or the present worth value. So that we have given as 1 minus into bracket 1 plus I by 1 plus b for a given number of years, that is 1 raised to n, into 1 by d minus I. So still if you simplify, when the discount rate is equal to inflation rate, b equal to I. So whatever increase in the money is there or decrease in the discount is there, if both are same, then the equation, above equation cannot be used. In such cases, what they are doing, they are substituting d equal to I. So still, if you reduce it, if the inflation rate or I is equal to d, finally what you can get is n into 1 plus I raised to n minus 1 divided by 1 plus I raised to n. So here 1 divided by d minus I was there. This will be cancelled because d is taken as equal to I. So that can be cancelled. Remaining this you have to simplify. After simplification, one can write n into n is number of years. N into 1 plus I raised to n minus 1 divided by 1 plus I raised to n. So that again simplified as after cancelling this 1 by I, 1 by I, you can get n by 1 plus I. If in the case of D is equal to I. So whether the proposed solar system is sound investment or not, one can also check by this present worth factor cost. So it can be determined only after comparison is made with the capital cost and future maintenance costs, all expressed in current yield. Because these all things are required to convince a customer whether he can go for the solar plant or he can quit his idea for the application. Next, we need to discuss about the present worth of capital and maintenance costs. The present worth of the anticipated savings must be compared with the present value of the cost of payments for capital and maintenance charges related to the investment. So these all things to be taken care in the initial stage itself. So in this present worth of capital and maintenance cost, we are going to consider one more factor, that is investment is to be paid in equal number of installments with interest charged at the rate of R. Whenever the interest rate is given R, in such cases we can find out what is the present worth factor if you pay the installments with the interest rate. In such conditions, what will be the extra amount to be paid for the given time. Okay, so that loan interest R itself is considered, okay, is different from the discount. So there's no discount from the company. In such cases, we need to pay the loan. So if you are paying the loan, then how to find out the present worth factor? Means after 10 years, what is the total amount you are going to invest and what is the present worth of that? Now we can write that present worth factor to find the amount of equal installments with the loan interest. In such case, just we are substituting in place of D. So here the value of D was there earlier, just we are replacing with R. Okay. So in such case, we can write it as 1 minus and I is 0. Very important. I we have taken 0 because money is not getting earned or profit is very less or negligible. Okay. So I is 0 and rate of interest only we are considering at discounts. So present worth factor now it becomes 1 minus. So earlier it was 1 minus I. Here 1 plus I or 1 minus I. That will be 1 only divided by 1 plus R raised to N. So 3 raised to N was earlier there. Just replace with R, rate of interest. So 1 minus 1 divided by 1 plus R raised to N, bracket into 1 by R. To take this term, one can find out the present worth cost depending upon the loan interest or the installment interest for the given number of years. Okay. So this is all about the theory behind our economical analysis on the solar system. Okay. So finally, we are going to focus more on the economics only. The plans and other wordings, what is given in the problems, are just for the namesake. We are just focusing on the rates, what they are given, like discount, inflation, or the rate of interest, or number of years. What are the values are given in the problem? That only we are directly taking and solving the problems. Yes. Now, in the first problem, you can see here, payback period also we have discussed just now. Equation for payback period you can just see here. What they have given is uh, with and without discounting the net present value they have given. You can see the problems only directly. You can use the problems. So net present value with discounting can be written as C into 1. C is the uh, what is C here? They have given C is the cost I think. Then 1 plus IF is the inflation rate divided by B. So here let us denote the symbol quantity, that is quantity by B. That is standalone system with savings on fuels and electricity. That saving factor they are given B. In case of an add-on system, if it is a hybrid system or a grid connected system, that is an add-on system. So that is denoted for the income derived from that sale of electricity from the system fed to the grid in the first year, also by the same symbol B. Okay, so both the saving from the system will be B. So using those equations, C into 1 plus IF divided by B for IF equal to D. In such case, if you want to find out the net present value, you can use this equation. Or if the discount is given, then you can go for this equation. So this is also one of the definition. The payback period is ratio of investment cost to the returns per year. If it is 1, payback period is good. So better we will solve some problems so that you can understand the importance of these equations. The first problem you can see here, a proposed insulation system for a house. So in the house, we are going to do the insulations outside or inside, so that cooling and heating effect will be loads will be reduced. so that we can save some money on the electricity. A proposed insulation system for a house to be heated is expected to save fuel cost of rupees 2000 in first year. Okay? So 2000 they are going to save in first year. The fuel prices are expected to increase by rupees 20%. So every year the fuel prices are going to increase by 20%. So that they have to consider. So that 20% is the inflation because the fuel prices are going to increase. Then, and best alternative investment will yield 10% per year. So alternative investment means you can keep the money in fixed deposit or some insurance you can claim. Within that alternate investment, it is 10% discounted money. Means earlier only you get per year 10% amount. So that discount rate is considered as 10% rate. To find the total saving from this proposed system expressed in the current value, take the life of the system is 15 years. So for 15 years, considering the discount if it is gone for the alternate method, okay, and if inflation is there for the year, so what is the present work factor? Whether you can go for the investment or not. So for 15 years, they are going to find. So taking this equation, present work factor 1 minus into bracket 1 plus I by 1 plus B raised to n into 1 by D minus I. So here they are not told discount rate is same as inflation because inflation is 20%, discount is 10%. So you cannot consider equal. So considering both are separate values, I can substitute and get the result as 1 minus 1 plus 20%, that is 0.2, 10% discount, I have taken 0.1, raised to number of years 15. 1 divided by discount minus inflation rate. So if you calculate all these curves, I will get the present work factor as 28.5. Okay, so the projected savings in the current value is 28.9 into 2000. Okay, the total amount to be invested, that is 2000 rupees, and present work factor to find out that is coming around 28.9. If I multiply both these things after 15 years, it is going to save our money or it is going to give the profit of rupees 57,800 rupees. Means by going by this system, the price is positive and it is going to save a lot of money just by saving the grid connection or the fuel supply. So like this, we are going to analyze the problem and we are going to just check whether the rupees is in positive or not and whether it is helpful for our going for the future applications. Similarly, next problem we can see a loan of rupees 80,000. Now see, loan is taken. Loan of rupees 80,000 is by the paid to bank in equal monthly installments over 20 months. So life given here is 20 months only. 20 months. Loan taken amount is 80,000 rupees. Bank interest rate is 15%. So interest rate is given. I will just replace this problem or equation with R. D I will replace with R. I will consider 0. So in that case, I have read the equation as present work factor equal to 1 minus 1 divided by 1 plus R raised to n into bracket 1 by n. Because I is not considered, D is replaced with R. Now taking these all factors into considerations, now interest rate, they are given only 15%. So per year, what is the interest rate? It is 1.25% per month. Okay, yearly it is 15%. But here installments paid in 20 months. So monthly payment will be how much? 15 by 12, 15. Per month, we have to pay 1.25%. So 5. Filling this 1.25%, that is 0.0125 rate of interest in 20 months, whether the present work factor is positive or not, we have to check. So that present work factor is 17.6, it is positive. Okay. Now as it is a loan amount, okay, we need to find out the monthly loan payment, how much will be there. The monthly loan payment will be 80,000 total loan amount. Then after that, we need to pay monthly. is the rate of interest. So using that present worth factor, if I divide, means monthly loan payment will be how much? 4,545.5. If this is less than the savings per month, then one can go for the application, or after at least payback period of the return on investment for some years. If this payment is going to be overcome, then one can prefer this plan or investment in this plan with the loan. Next condition they have given B, question B. The question A was with this loan amount and interest. B question is if the borrower should have invested rupees 80,000 at a rate of 12%, then what is the present value of rupees 80,000? So alternatively, what they are telling, if he has invested this amount in some other investment and he could get 12% returns. So they are asking now viewers, so what will be the present value of this money? So the present value of this money can be found out. So they have assumed something here like expect the monthly rate of interest. So here monthly rate of interest 12%. So per year they are going to find out 12 by 12, that's 1% rate of interest, 1%, 0.01. That they are going to substitute in the given formula for 20 months. So as here months and other things are not given, they have considered the main equation itself, main problem. So using these values in the formula, now one can find out the present work factor is positive 18.04. Now see the present capital cost of 80,000. How much it will be after, say for example, 20 months. Okay, the present work factor is 18.04, and if they pay the same amount for this present work factor, then the amount would have increased 82,000 rupees. Okay, after 20 months. If the alternative source was there, say for example fixed deposit or some recurring deposit, something they have invested, they might have earned this much of amount by paying same amount, 4,545. But if they have spent in the solar plant or this plant by taking the loan, then they would have paid 4,545 every month. But there it is not, money is not growing, but it is reduced. Next problem is, I think another, okay, we will finish up the problems today. Yes, next problem is the maintenance cost of a solar heating system over its lifetime is rupees 800 means it is 800,000, 8 lakh rupees. 8 lakh rupees is only on the maintenance of the solar heating system for its lifetime. Find the present value of maintenance cost. The first year cost is 40,000. Okay, first year maintenance cost if it is 40,000, then find out the present value. And inflation rate is 10%. The best alternative investment rate available is 12%. But if we don't choose this solar heating system, if we invest somewhere else with 12% return, what is the present worth factor? The life of the system is 12 years. Consider 12 years and find out both the applications. So present worth factor for the given system can be calculated by using this equation. Again, same thing. 1 minus into bracket 1 plus I by 1 plus d raised n into 1 by d minus 1. So here in the problem, they have given the inflation rate 10% directly. Okay. Return or discount received from the other alternative investment is 12%. So discount is also considered 12%. Number of years they have given for 12 years. So n is 12. So take all these values and substitute in the present worth factor. The present worth factor we are getting 9.7. So 9.7 per year if you invest or if you give the money for the maintenance 40,000. So what is the total amount paid on the maintenance, it will be 3.88 into 10 raised to 5 at present. So much of money is required only for the maintenance cost. Okay, so that they are asking. Last problem, a solar PV street lighting system. You can assume one that imagine solar PV street lighting system is there, consisting of two lamps. So imagine two lamps with two poles, two lights are there. Three PV modules are connected. A battery and other associated components cost rupees 55,000. Battery, other things like wiring, then many circuit connections, PV modules, and two lamps. All these things cost 55,000 rupees to erect two poles with the two street lights and three modules. 55,000 is investment is required. The cost of conventional energy saved due to installments in rupees 4,000 in first year. Here, what is the amount saved now by using this PV street light? We are going to save the cost of conventional energy saved due to installation is rupees 4,000 in the first year. So only in the first year, 4,000 you are going to save. And this cost inflates at the rate of 5% per year. Okay, so there is having some inflation that is 5% for this 4,000 rupees. Calculate the payback period. And now we have to go by net payback period. That is NP value or net payback value. NP. This formula have to use. So by that formula, NP is 1 minute. Calculate the payback period with and without discount. So considering D and without considering D of the system. So if you consider discount, you have to consider 9%. All these things are given. So just you can rewrite the given terms like payback period NP. Then the inflation rate is 5% per year. Okay, 105. Then C is initial investment required or cost of components. Total cost of components is 55,000. That is C. Okay, what we are seeing here, that C is total cost of the equipment. Then B is cost of conventional energy saved. What is the amount you are going to save if the alternate system is used? If the solar PV system is used, I would have saved 4,000 rupees in first year. So that 4,000 for first year I will consider in B. So now what is the equation for payback period? NP equal to ln of IF into C by B plus 1 divided by ln of 1 plus IF. Using this equation, let's substitute all the values given. IF is given 0.05. Total cost is 55,000. Inflation rate is 5%. B is the saving by the conventional system. So after avoiding the conventional system and going for the PV street lighting, the saving per year is 4,000 rupees. So that saving B is 4,000. Inflation rate is 5%, 0.05. So all values is substitute. Now one can find out what is the payback period. So that payback period you have to write in years. So ln of 0.05 into 55,000 divided by 4,000 plus 1 divided by ln of 1 plus 0.05. So totally in 10.7 years, all the amount invested today with savings per year, after 10.7 years, the net amount will be zero. Whatever is invested, whatever is gained, after 10.7 years, you are going to get only the returns. Only the profit will be there after the 10.7 years, like that. Now, if the discount is considered, now equation will be different. So with discounting of 9%, 0.09, what's the equation? Ln of 1 minus, let's see here, ln of 1 minus C into D minus F by B divided by ln of 1 plus IF divided by 1 plus B. Same equation they have used here. Ln of 1 minus D minus IF into C or C into D minus IF divided by B whole divided by ln of 1 plus IF divided by 1 plus B. So substitute all the values given in the problem with discounting. That's all. With discount if you consider, what will happen? Now I'm going to gain after 21.4 years. So until 21.4 years, with the discounting, if you see, what will happen? I have to wait for 21.4 years. Later that, I'll get some rate of returns on the profit. Okay, I hope all these problems are understood to everyone. If any doubts are there, we can discuss in the next class and we can complete this chapter. Let's stop the class here.